Okay, Reagan. What is this?
Earth.
Okay. And then what is this little guy?
The moon.
Yep. So this is how big they are compared to each other. But if they were really this big, the Earth would be here, and the moon would be over here, 50 inches away. That's a lot of clay. So I did not do that. Okay. Now, what is gravity? Show me gravity with this marble. But what is it though?
When it falls down.
Yeah, gravity is where something that's really big, like the Earth, pulls things towards it, right? And so when you drop this marble, gravity pulls the marble towards the center of the Earth. Now, why doesn't the marble reach the center of the Earth?
Because the ground?
The table and the ground gets in the way, yep. So the way that we visualize gravity mathematically is a hill, right? Mm-hmm. So if I put this marble here and let go, what's going to happen to it?
It's going to go down.
It's going to go down. Yep, see? No, it's sticky. But it goes down towards the Earth, right? That's gravity. Now the moon also has its own gravity, right? Mm-hmm. But why is the moon's hill not as big as the Earth's hill?
Because the moon's not as big.
The moon's not as big, right? So the strength of gravity depends on how big the object that is pulling it is, right? And so what do you think has more gravity? The moon or Mars? Mars. What about Earth or Mars?
Earth.
What about Earth or the sun?
Sun.
The sun is massive, yes. So Earth has a bigger hill, a bigger slope around it. That's its gravity well than the moon. Okay? Now when we launch something to the moon, we have to put so much power behind it that we've got to get all the way up to the top of this hill. Otherwise, if we don't have a rocket that's big enough, we fall back to Earth. So that's how we get from the Earth to the moon, is by launching up this hill, up here, and then going down the hill to the moon. Okay. Now, what's orbit?
When something's circle.
Right, and so this is going to be hard to do on this clay, but if you were to, instead of just letting the marble go, if I were to flick it like this, you see how it goes around in a circle? Mm-hmm. If I flicked it fast enough, it would go around multiple times. 3, 4, right? Let's see if I can get it to go around one time. Oh, man. You got to flick it really fast. Ooh, see, that one almost escaped. But you see how it's going to circle? So that's an orbit. And so the way that we get to orbit is we go high above the Earth, and then the rocket actually turns, and instead of burning up, it turns and it starts burning this way to get us going really fast so that we stay on this circle. It's like at the museum when you put the pennies down those slopes and they go, whoosh. That's orbit. Okay. Now, so if we have something in orbit here, it's going to move in a circle around, right? Okay. But there's a couple of special places between the Earth and the moon where the gravity is equal. So the pull of gravity from the Earth is equal to the pull of gravity from the moon. And what do you think happens there? Can you leave that there, buddy? You play with that clay. Here, you have Mars. You have Mars. So what do you think happens at a place where the Earth is pulling one way and the moon is pulling the other way, but because of where it's at, the strength is the same?
It stays in the same spot.
It stays in the same spot, right. So, can you find a spot?
Even it can roll. Even it rolls.
Yeah.
To try to get to somewhere where it can fall, or it can get to somewhere placed down.
Yes, that's right. Reagan, can you find a spot on here where the gravity is the same? Yeah, that's one.
See, like that, it's rolling slowly.
So here's one, right? So if I put the marble there, the gravity is the same, right? There are 4 other spots where the gravity is the same. Can you find them?
That's my gravity.
They're hard to find. No?
Gravity.
I'll give you a hint. 3 of them are on a line like this.
When someone drops it.
Yep. So one is there.
When someone drops it.
Kenneth, buddy.
And then there's another one, right? So if I put it here, it'll stay, right? And then where's the other one? Yep, so there's another one there. Now the other two are hard to find. Can you find them? Yeah, it's actually right about here. Right, and now it's just hard because this clay is kind of sticky, but you see these little peaks right here and right here? So that's one, right? If I'm a little bit off the peak, I go down. If I'm a little off this way, I go down. But if I'm on that peak, I will stay on it. If I'm a little bit off, it'll go down. Yep, so there's one there. And where do you think the other one is at? Yep, it's symmetric. So put that one there. So these 5 points are called Lagrange points.
Lagrange points.
Lagrange points. They're also called libration points.
Libration points?
Yeah, so they're named after a guy who discovered them, who said, if you have two bodies exerting gravity, because gravity gets weaker the farther you get away from it, right? If you have two bodies exerting gravity, eventually they'll have a spot where their pull is equal, and we can actually put a satellite there, and it'll just stay there, and it doesn't roll off. Right? We can't put it here, because it'll go down. Can't put it here, because it'll go away. But we can put it right there. So if we have a satellite here, it'll always stay here, instead of a satellite here that has to go around in circles. And so what do you think would be the advantage of a satellite there if I was trying to go back and forth between the moon?
It's easier to control.
Yeah, it's always in the same spot, so it's predictable, right? So what could I use that for? It could be a stop, right? So we leave the Earth and we stop here and we rest, because it's a long journey. If you want to get up this hill, straight up this hill, it's about 5 hours. But do you ever walk straight up the hill? Like when you go to your bedroom on the 4th floor, do you climb up with a rope? No, that's hard, right? How do you get up there?
It's like stairs.
Stairs. Yeah, it's slanted. So instead of going straight up here, which is the fastest way, you could go around, right? And you're walking farther, but it's a little bit easier, right? Until you get up here, and then you can rest, and then once you're here, what's the good thing about being up here?
You can go either
You
way.
roll downhill to the moon, right? Right, because you're up here. So you can either, from any Lagrange point, from these three right here particularly, you can get to that point, and then you can roll either downhill to the Earth, which is really easy, boop, back to the Earth, or you can roll downhill to the moon, like that. So these Lagrange points could potentially be used as like rest stops or pit stops to help make our trip to the moon easier and more efficient. So now,
Or a ladder in your house to go up to get to your bedroom.
yeah, a ladder would work too.
And stairs.
Yeah. So that's one of the challenges in the book that I'm reading, is that they grow grain here on this planet, and it's really cheap to ship from the moon to the Earth, because you can just, you see you have this little ledge. It doesn't take a lot of energy to go over that ledge, and then you just fall down to the Earth, right? But the moon, they're sending all of their good grain to the Earth, but the Earth isn't sending anything to the moon. Why not?
Because you have to go all the way up and then down.
Yeah, so it's really expensive to do that, right?
Yeah.
Right? And so the moon, these guys on the moon are like, hey, we're sending you all of our good grain, right? And you're not sending us anything in return. And the Earth is saying, well, it's too expensive for us because we've got to ship up this hill, right? And so that causes a lot of tension between the people who live on the moon and the people who live on the Earth. Kenneth, can you explain what you did? What'd you do?
I'm making, okay, but I'm not done. So when I'm done, can I tell?
You can tell it now just as a start, okay? So tell us what you're making.
This is a sun.
Okay.
So we have sun, gravity, Mercury, gravity, Venus, gravity, Earth, gravity.
Okay. And then what are you going to do?
Mars.
Mars, yeah. But why don't you have enough clay?
Because it's a big gravity.
Yeah, because I used it all, right?
Yeah, you use it all.
Yeah, so I think we got it on tape now. I think that you can use all the